Let's say you're given a graph. If you were to go along this graph, you'd reach a point where a hole exists. If you were to try to calculate the limit of this hole, you'd end up with 0 over 0. This is known as an indeterminate limit.
So one way to evaluate a limit when it's indeterminate is to factor it and see if you can eliminate a factor so that you can get a limit that is not 0 over 0. So let's say we have the problem limit as x approaches 2 of x cubed minus 8 over x minus 2. So if we were to plug in 2 to this equation, we'd get 2 cubed minus 8 over 2 minus 2, which would evaluate to 0 over 0, and that's indeterminate. So we need to figure out some way to factor this equation, or this function, so that we can get an actual number for the limit. Now in this case, you'll notice that the top has a cube in it. Now there's a special set of rules that you can use when you're factoring cubic functions, and these are rules you should probably memorize, as they will be very helpful with this kind of problem. Those two rules are the sum of two cubes, which states that a cubed plus b cubed equals quantity a plus b times quantity a squared minus ab plus b squared. And then there's also the difference of two cubes, which states that a cubed minus b cubed equals quantity a minus b times quantity a squared plus ab plus b squared. Now in the case we have here, it would be the difference of two cubes, because we have an x cubed and we have an 8. And 8 can be evaluated with a cubed root, and we would get 2. So let's factor the top portion of this function using the difference of two cubes method. So to do that, we will do x cubed. Okay, so the cube root of x cubed would be x, so that'll be our a value, and the cubed root of 8 is 2, so that will be our b value. We will have x minus 2 times x squared plus 2x plus 2 squared. Now if we want to simplify this a little bit, we can write it as x minus 2 times x squared plus 2x plus 4. Now if we want to rewrite this in the original function, we would write it as x minus 2 times x squared plus 2x plus 4 over x minus 2. Now, since we have an x minus 2 on the top and an x minus 2 on the bottom, we can cancel the 2, and we would be left with x squared plus 2x plus 4. Now we can find the limit as x approaches 2 by just plugging in 2 for x. And if we did that, we'd get 2 squared plus 2 times 2 plus 4, which comes out to be 12. Sometimes the factoring for these functions is a little simpler than it was for the cubic functions. Take, for example, the function x squared plus x minus 6 over x plus 3. If we were trying to find the limit of this function as x approaches negative 3, we could first try to just plug in negative 3 and see if we can get a number. In this case, however, we would get 0 over 0, the indeterminate form, which is unusable. So we need to factor this in some way to remove the x plus 3 on the bottom. So this is basically the same idea as we did with the cubic functions, except this time we're just going to be factoring a trinomial on top. So there are several methods of factoring trinomials. I'm sure you can pick whichever works best for you. I just like to sort of look at the function and kind of trial and error it. So if we were to break up x squared plus x minus 6 into two factors, we would get x plus 3 times x minus 2. Now if we rewrite our original function, we would rewrite it as x plus 3 times x minus 2 over x plus 3. Now, since we have an x plus 3 on both the top and the bottom, those can cancel, and we're left with just x minus 2. And now we can go ahead and plug in negative 3 for x to find our limit, and that'll give us negative 3 minus 2, which is negative 5. So one way of finding the limit of an indeterminate function is by rationalizing the numerator. So, for example, if we had the function the square root of x plus 1 minus 1 over x, and we were trying to find the limit as x approaches 0, if we were to just plug in 0 to the equation as it stands, it would come out to be the square root of 0 plus 1 minus 1 over 0. And if you were to evaluate that all the way out, you would get 0 over 0, which is indeterminate. So that's no good. We can't do that. So what we have to do is multiply the top and the bottom by the square root of x plus 1. And this is called rationalizing the numerator, because we're taking the square root in the original function and multiplying it by another square root. And the effect that that has is that it pretty much eliminates the square root, because you are basically squaring a square root. So, once we carry out that multiplication, we would come out to get x plus 1 minus 1 over x times the square root of x plus 1. And now we can go ahead and cancel some things out. So on the top, we have a 1 minus 1, so that'll go away. And then we also have an x on the top of the fraction and an x on the bottom, so we can go ahead and cancel those out, and we would get 1 over the square root of x plus 1. Now we can go ahead and plug in 0 to find the limit as x approaches 0, and if we do that, we would get 1 over the square root of 0 plus 1, which would come out to be 1 over the square root of 1.
One tool you can use in order to find an indeterminate limit is synthetic division. This is useful whenever a polynomial is too large to be able to factor out simply. Say you're given the formula x cubed minus 2x squared minus 9 over x squared minus 2x minus 3. And the limit is x approaches 3. If you were to plug 3 into this equation, you'd end up with 0 over 0, which isn't good for an indeterminate limit, and it gives you an indeterminate limit. It's not something you can use. So, in order to do this, you'd factor out what's causing the 3. So if you factor the bottom out, you end up with x minus 3 times x plus 1. You can see here that the x approaches 3 is causing the x minus 3 to equal 0, and that's the source of your 0 on the bottom. In order to be able to get rid of this, you have to find the same equation on top. X minus 3 has to be factored out on top. So, with the 3 in mind as the number you're going to have to find for the top equation, you put it over in the box to the right and begin synthetic division. First, you line up all the coefficients of each number. You have x cubed, well, there's one x cubed, so you put a 1. You have minus 2x squared, so it's negative 2. Now, notice there is no x. Even though there's no x in the formula, you still have to put an equivalent place value of it. So in this case, that'd be 0, since no x is there. And lastly, you have negative 9. So this is an addition problem. You're going to go ahead and add down. 1 plus nothing is 1. Now you take this bottom value, multiply it by the factor you need, 3 in this case, to get the number for the next addition. So you have 1 times 3 is 3. Then you add negative 2 plus 3. You end up with 1 again. Multiply 3 by the 1. Go back up and you have 3. It's 0 plus 3 is 9. 0 plus 3 is 3. Lastly, 3 times 3 is 9, and negative 9 plus 9 is 0. So now you're left with 1, 1, 3, and 0. These become the coefficients of your full quadratic equation. So 1x squared plus 1x plus 3, and with the remainder of 0. And this is multiplied by the original factor you're trying to solve to remove, x minus 3. Now we have the full equation, x squared plus 3 times x minus 3 over x minus 3 times x plus 1. Now that you have an x minus 3 on the bottom and top of the equation, you can cancel it out, and you're left with x squared plus x plus 3 over x plus 1. With this, you can evaluate as limit x approaches 3, plug 3 back into the formula, and you're left with 15 over 4. And that is your limit.